Time travel at the speed of light is a concept derived from Einstein's theory of relativity, which suggests that as an object approaches the speed of light, time dilation occurs. Time dilation refers to the phenomenon where time appears to slow down for an object in motion relative to a stationary observer. According to this theory, if an object moves at the speed of light, time essentially stops for that object, and if it goes faster than the speed of light, time goes backwards. This means that if someone were able to travel at or near the speed of light, and then return back to their starting point, they would experience less time passing compared to those who remain stationary. This effect is known as time dilation and has been experimentally verified using high-speed particles in particle accelerators. However, it's important to note that traveling at or beyond the speed of light is currently considered impossible according to our current understanding of physics. As an object with mass approaches the speed of light, its energy requirements become infinite. Additionally, objects with mass cannot reach or exceed this speed due to relativistic effects. Time travel with wormholes is a theoretical concept that suggests the possibility of traveling through time by utilizing the properties of wormholes, which are hypothetical tunnels or shortcuts in space-time. According to general relativity, wormholes can connect two distant points in space-time, potentially allowing for faster-than-light travel. The basic idea behind time travel with wormholes involves manipulating the geometry of space-time to create a shortcut between two different points in time. By entering one end of the wormhole at a specific moment and exiting through the other end, it is theorized that an individual could effectively jump through time. However, the existence of traversable wormholes that can be used for travel, is purely speculative and has not been observed or created in reality. Time travel through suspended animation refers to a hypothetical method of traveling through time by temporarily suspending or slowing down the biological processes of an individual. This concept suggests that by placing a person in a state of suspended animation, where their bodily functions are essentially paused or slowed to an extremely low level, they could potentially survive for extended periods without aging or experiencing the passage of time. The process of achieving suspended animation for time travel purposes would involve cooling the body to extremely low temperatures, typically near absolute zero, which would significantly slow down cellular activity and metabolism. This could be achieved through cryogenic techniques, where the body is preserved in a state of deep freeze using advanced technology. Once in suspended animation, the individual would essentially be in a state of hibernation or stasis. Time would appear to stand still for them, while the outside world continues to progress at its normal pace. The idea is that when the person is eventually revived from suspended animation, they would find themselves in a future time period, having effectively traveled forward in time without experiencing any of its duration. Time travel with gravity, also known as gravitational time dilation, is a concept in physics that suggests time can be influenced by the presence of strong gravitational fields. According to Einstein's theory of general relativity, gravity is not just a force, but also a curvature of space-time caused by massive objects. In this context, time travel with gravity refers to the phenomenon where time can appear to move at different rates depending on the strength of the gravitational field. The closer an object is to a massive body like a planet or a black hole, the slower time will pass for that object compared to an observer in a weaker gravitational field. This effect has been experimentally verified and is commonly observed in satellite-based systems like GPS. Satellites orbiting Earth experience slightly faster time compared to observers on the surface due to their weaker gravitational field.